Good morning, good afternoon, good evening, everyone. This is Jim Bashford coming to you from Westfield, Massachusetts, SpacePak's headquarters. Looking forward to walking you all through today's factory authorized air-to-water heat pump training. I'm not sure if everyone heard my intro previously. We're going to get started here in mere minutes. Appreciate everybody for coming. We still have some folks logging on, so we want to make sure we get everyone on that wants to from the beginning. That helps the question and answer process, and understand that some people have some technology delays, right? We're all dealing with that one way or the other. I am talking now. If anybody does hear me, they're welcome to type into the either questions or chat, just letting us know that everyone can hear. Going to pause my mic for a moment, and then once we reconvene in a couple of moments, we will jump right into it. All right, again, good morning. This is Jim Bashford with SpacePak. Looking forward to walking everyone through the factory authorized training here for air-to-water heat pumps. There will be a couple people logging on late, as that usually happens, but we don't want to keep all of our very attentive and astute original attendees waiting too much longer. So we'll start diving right into things here. I'll do a little intro, then I will pass the mic, so to speak, over to our marketing manager, Meagan Harrington, who sits here alongside. And we are thankful to have her putting together a lot of our presentation and marketing material for SpacePak. If you have any questions, we'll probably mention this multiple times throughout the day, or the morning or the afternoon, wherever you folks reside. Please use the taskbar, the GoToWebinar taskbar, to input and ask out any questions that you may have. We have a team, our team here from SpacePak of design engineers, product managers, and such, available to answer questions in real time as they come in. If questions get answered multiple times, they'll let me know. We may pause for a second. I'll get the question and then basically ask the question, then answer it aloud so that everyone can hear. So from time to time, I'll collect information from them during certain question slides, if you will. And if anything seems super prevalent, I'll make sure we bring attention to it. So what's appreciated is that when and if you do have any questions, you ask your questions right away, basically, before we would essentially get to another portion of the program and then have to backtrack. Just makes things easier for moving through the presentation.
Alrighty, hello everyone. I'm just going to do some introductory housekeeping slides and a quick little bit of history for you. As Jim said, everyone keep your audio on mute. And we'll probably get asked many times today whether or not you will receive a recording of this webinar and if you'll get a copy of the presentation, and the answer is yes and yes. Tomorrow, basically 24 hours after this webinar concludes, you will get an automated email that will include a link to the recording of this webinar, as well as a link to download the PDF copy of today's presentation, along with many other resources that you can download and get at that time. So no need to worry if you don't get it today. You will definitely get it tomorrow. So all of you are familiar with SpacePak, but you might not be familiar with SpacePak's parent company, Mestek. Mestek, you're probably also familiar with some of the other brands under the Mestek umbrella. Established in 1946 here in Westfield, Mass. Our founder actually was the national sales manager for Smith cast iron boilers at the time, which Smith cast iron boiler foundry was here in Westfield, Massachusetts. He ended up leaving Smith and basically producing the first copper fin tube baseboard radiation in the country. And to this day, baseboard is still our bread and butter. We manufacture most of the world's baseboard, or North America's baseboard, here in Westfield, Mass. Today. So from there on out, our founder pretty much started acquiring synergistic HVAC companies over the years. And in 1991 was when SpacePak joined that Mestek family. So we have a long history in specifically the niche of heating and cooling with water, hydronics. So here's another quick glance at Mestek's larger makeup, our 3 divisions. We also have an architectural division and a machinery division, but we are focused on the HVAC division. And we have residential and commercial. So here's just a quick snapshot of some of our commercial boilers that you might recognize: RBI and Cayenne cast iron boilers, ATH. Here's a quick snapshot of a commercial heat pump company that we have up in Ontario called Transom. And so there's a lot of synergies there, as you can see. And another screenshot of just some other Mestek products: Sterling HVAC rooftop products, hydronic unit heaters, and some commercial fin tube baseboard there. And as you can see, Mestek's footprint is quite large across the country. We are in Westfield, Massachusetts today, where our headquarters and home base is. That brick building you see there on the left is actually the building that we are inside of, and it's home base for our product and engineering, sales and marketing, accounting, finance, IT, all that jazz. And here in town, we also have our research and development lab, which is a great place. We love to bring people who are in town over there because they're always doing really cool stuff over there. And as I mentioned, our manufacturing for all of our baseboard line and some of Mestek's other products. And we also have our Reed Institute, named after our founder, John Reed, which is our training and education center and showroom. The person presenting today will be Jim Bashford, who is our National Sales and Training Manager. He's been with SpacePak for over 7 years. In addition to his role as National Sales and Training Manager, Jim has used his extensive knowledge of all of SpacePak products to continually expand his role within the company, taking on greater responsibility with the training side of the business, including instructing our SpacePak systems and application seminars. Before joining the SpacePak team, Jim was a manufacturer's representative for 3 years, working with a variety of HVAC products. He has over 23 years of experience in the HVAC industry, which includes experience as a contractor himself and business owner, where he spent many years selling and installing SpacePak products. That's actually how he got on our radar at the time. Our national sales manager ended up on a job with Jim, and he liked him and his work so much that he asked him to come work with us, and here we are today. I'm going to hand it back off to him now.
All right, everyone. Megan, thank you very much for that overview of the company. Listen, guys, as you can see, right, we're a deep company. SpacePak as a whole, as an entity, is I don't want to say we're small by any means, but compared to the scope of or the reach, if you will, of what Mestek is as a whole, okay, it's kind of the best of both worlds, right? SpacePak, I say, is that big, small company. It's small in the matter of if we have something, a situation, a question, a comment, a concern that needs to be addressed, you can get to the person or people that will make that, will answer that question, will handle that request quite quickly, right? There's not a lot of that red governmental tape, if you will, to kind of get to the source and the reason and to get a resolution to that question, comment, or concern you might have. Not to mention, if you want to say something's great, we also accept positive feedback. So anytime you want to say something not so good, we welcome 2 or 3 positive feedback points to accompany that. So we follow those rules, we'll all be super happy. With that said, Mestek, our manufacturing facility, is in Farmville, North Carolina. That's where we manufacture our air handlers, our small duct, high velocity air handlers. And we're also, all of the warehousing goes for our air to water heat pump equipment, buffer tanks, and all the other cool new stuff that we're working on here in SpacePak land. So some of you may be very familiar with SpacePak air-to-water heat pumps or air-to-water heat pump technology in general. Some of you may not. If you're looking for, after this presentation, more information about SpacePak technologies, please visit our spacepak.com website. From there, you can find what would be your most local or closest manufacturer's representative, right? So each area within the country, and we'll kind of break it down a little bit for you coming up, has basically a manufacturer's rep that works for SpacePak, right? That is commissioned by SpacePak to support our product through the country. It's not a new way of doing things, right? It's a way for us to very easily and more clearly give very specific targeted support to our customers throughout the country, right? More people on the ground being able to service our ever-growing customer base. So first line of defense for some information, once you hit up spacepak.com website and read all the cool stuff we have on there, is to look a little deeper and talk to your local representatives if you're a contractor. And that contractor reaches out to the representative and is then able to start discussing things like, hey, where can I find this equipment? What wholesaler close to me does sells and offers this type of equipment? We look at this state. Sorry, we don't have a breakdown of Canada, so I apologize if there's anyone from way up north there that are attending today. We do have some options for representation there as well. But as you can see with the different color states, I'll kind of scroll through this quick depending on where we're meeting up from today. I'm pretty sure we have some representation from pretty much most of the major cities in the country today. So we always look forward to seeing who signed on to this, before, during, and after we do these presentations, right? There's definitely some hot spots in the area. Certain regions in the country are far more interested in this electrification type technology than others, but inevitably throughout time, there will be a place for this type of technology, whether it be sole source or alongside things we are potentially more familiar with, like fossil fuel heating and normal DX cooling. To give a little lineup here, we're going to try not to make this too sales pitchy, but what I like to do is show you where we came from, right? And give you an idea and an understanding that if you only heard about an air-to-water heat pump or what an air-to-water heat pump might be last year or the year before, that's certainly not the first time they have been in existence, right? And certainly not the first time that we have sold air-to-water heat pumps in North America, right? We introduced air-to-water heat pumps to North America in somewhere around 2010, 2011, and have evolved with the technology throughout the years until where we are today. And this just shows that timeline, and it allows you, as Megan had mentioned, to just kind of visualize and understand our dedication as a company to this technology, the evolving parts of the technology, and always working to kind of make our equipment not just better, but simpler. Right, we're going to go over today. This is the stuff we're going to learn, right? We're going to learn the things that are super basic to some, but if they don't get said, they just simply don't get said, right? We're going to find, I'll give you the 5 or 6 things throughout this training that's going to allow you to essentially install these units correctly, right? And they're really, really quite simple machines, super advanced with the brains that they have and how they run and their efficiencies and such. Installing them can be just as easy following these basic steps we're going to unveil today as we roll things out. So here we are. It's a kind of a cool picture. We have a couple other pictures. This one's a large project that we'll talk about a little bit later in the presentation, but we have 6 air-to-water heat pumps. This is actually our ILAHP, so it would be a cold climate air-to-water heat pump. This unit will actually deliver space heating temperatures well below 0, actually down into the -20s in the Fahrenheit column. So pretty versatile equipment. We're going to really kind of dig into the versatility of them. And just looking at this picture now, they're looking pretty good setting there. SpacePak does offer a pre-sales application support team. That handsome gentleman in the picture, Eric Rainey, kind of heads up that department. Basically, our inside sales team working with and for system application, helping with some equipment selection, and probably the most important part of any HVAC project, no matter where you are on this planet, is knowing your load calculation, right? If we're going to be heating, how much heating do we need? If we're going to be cooling, how much cooling do we need? Eric, on a very daily basis, answers some of the most basic questions to some of the more complex questions as well. So super great resource here for not only the contractor to use, our rep organization of reps uses as well, along with wholesale distribution, outside sales, and things of that nature. So it just adds to our system of checks and balances to make sure that these projects all go off as fully intended and work properly. So one of the perks of taking the presentation today, other than learning all of the really cool basic things and listening to me talk for 2.5 to 3 hours, is the fact that as a contractor, once you are certified and once you basically give us your information, right? Just basic stuff, shoe size, blood type, social security number. We will then enter you as into being a certified contractor. And we're kind of going to go into that here in the next couple of slides, understand how that works. But what that allows you to do on the air to water side is offer what would be a longer warranty than a non-certified contractor. So 5-year parts, 10-year compressor warranty on all of our air to water heat pumps that we offer to this day to certified contractors only. So for your extended warranty to be inact or functional or valid, you need to be listed as a SpacePak certified contractor at the time of installation, and you must register your project or equipment via the website. And we'll kind of go over that here coming up. You get your extended warranty as mentioned. You'll be listed on our website as a SpacePak.com or a SpacePak air to water heat pump certified installer. You'll receive homeowner leads. You have access to our pre-sale support, and you have access to marketing support as well with some available co-op dollars. So how this works, let's just say that you're A, B, C, D, E, F, G refrigeration, and you take today's training and sign up and give us your company's information. Information will then be inputted into our contractor locator, and then basically what happens is a homeowner or end user or interested party of any sorts would hop on our SpacePak.com website looking for some information. They would fill out a pretty elaborate question and answer about their project, right? The more questions that they answer, the more information we have about their project. And then they get to say, hey, I'm in this area. Here's my zip code, and I want to know how many certified contractors are within in this case, shown in this picture here, a 30-mile vicinity from my home. And from there, they can submit their interest, right? They can submit their lead, and one of those 3, if not all 3 contractors will get that information. Basically, that customer is saying, please, I'm interested in learning more. Please reach out to me. We do not have a true closure percentage, but I can promise you that when someone goes the distance to fill out our forms and answer our questions, they are more than willing to take a phone call and potentially even a sales and site visit from the contractor to get more information about doing their work. When the homeowner were to sign on, they would pretty much say, hey, am I the homeowner, am I a contractor, architect, or other? And this is just one of multiple steps of the information that they would fill out. Once you get the job, you install the job, and you want to register for your warranty as a certified contractor, right here on our website, we go to product registration. Initially, it'll pop up asking if you're the homeowner or the end user. If you log on as the homeowner or the installer, if you log on as the installer, which is what I recommend doing, you basically have to have the information for the equipment that you put in. If there was a serial number on the piece of equipment, then it needs to be registered, right? If there's a model number for the piece of equipment, it needs to be registered. And I suggest you do that, as you'll have, meaning the contractor would do that, as you'll have better access to that information, and you'll also already have the homeowner's information, which would need to be inputted as well. So you saw the evolution of our offering from 2011 and on. Currently, our offering consists of quite the portfolio of air-to-water heat pumps, right? We're going to break all of these down here. So we've got 410 equipment, we've got R32 refrigerant-based equipment, and then potentially in the near or not so near future, depending on government regulations and the upcoming November election, we will or may have opportunities to offer even more exciting equipment. So one of the things we always kind of get the round robin on is when you get the energy efficient equipment, right? Energy efficient equipment generally doesn't come in a buy one, get one free platform, right? So no big sales, right? There's no, you don't buy a gallon of milk and get a heat pump for free. So people look for different ways to save money on their project, right? And that's generally done through localized state, county, and even sometimes governmental rebates. Now, air-to-water heat pump rebates have not gotten a fair shake in this country for quite some time. However, things are very much starting to open up and progress the way that we kind of wanted them to, I don't know, 5 or 6 years ago, right? There are some very well established, if you're in any of these areas located here on the left or even in New York, there are some very significant and established, as I mentioned, rebate programs throughout the country. Talk to your local municipality. A lot of times the devil, so to speak, is in the details and the terminology, right? When we look at on the right here, prior to 2024, it only applied in New York, their heat pump rebate only applied to geothermal air-to-air and heat pump water heaters, right? Air-to-air meaning your standard outside condenser, if you will, right? Or matched up ductless mini split, that type of situation. Well, they're finally starting to include air-to-water heat pump as a viable heat pump option. Not that it hasn't always been, but as you can imagine, the acceptance of new equipment when it's not necessarily understood, folks generally tend to hesitate. We have the and more up there, right? Because there are more. It would be virtually impossible for us to scour every local town and municipality rebate program offered. My suggestion to you as a contractor is to reach out to your local energy providers and find out these things. A lot of times they will even do a lot of the paperwork for you to help you along with that homeowner and using those rebate programs. This is kind of, some of you may know this, but let's think about it. The only good rebate program is a successful rebate program. The people that put these rebate programs together want to spend the money they have. If they don't spend the money they have, then their program's not viable, and there literally could be jobs on the line because of it, right? When the government gives you money, when the state gives you money, you need to get rid of it. So it's very unlikely that you will find a local township, municipality, or what have you that is not willing to work with you as a contractor or homeowner in the future moving forward with air-to-water heat pump rebates. Whew. All right. So even though the world was slow, right, to recognize these rebate things, we spent a little bit of time on it because it's important, right? What does a rebate do? It basically makes something on sale. Who wouldn't want something to be on sale? If you're going to buy it, you might as well buy it when it's on sale. So in 2018, a little timeline here, Vermont established the first rebate in the country based on one of our original cold climate heat pumps and a unit that we used on a Habitat for Humanity project. In 2019, we were recognized for the Energy Stars Emerging Technology Award. And 5 small years later, AHR finally dedicated a working group to the establishment of a federal performance standard for the air-to-water category, since none currently exists. So change is coming, right? Positive things are definitely on the horizon for this technology. And once the AHRI standard is established, we expect local utility and IRA incentives to follow, right? It'll be very easy for a local township municipality that has some state funded money to use, right? Again, we need to get our state funded and we need to spend it, otherwise we don't get it, whether it's for sand and salt mixture for the roads or a rebate program. The money needs to be used and circulated through the township. If that's not the case, they won't get more for next year. So I'm looking very much forward to what is to come in the next year or two as far as rebates and at least the understanding and appreciation of this technology. Whew. I'm going to take a quick pause. I'm going to make sure no magnificent questions came up. I'm going to pause my mic just for a second. I'll be right back with. All right, I'm back. We had a couple of quick questions. One of them revolved around inflow cooling, which we'll get up to here. And then the other one was a question about rebates in Maine. So rebates in Maine are a little bit tricky. They're definitely working on it. My suggestion to you would be to advocate for it and reach out to the Efficiency of Maine program. Okay, definitely a state that's looking to make some things happen. They are just kind of in the paperwork stages. So look forward to that and reach out to them directly. All right, let's get into things here, okay? Oof, crack your knuckles, stretch your back, buckle your seatbelts, and get ready for this amazing ride through the technology of air-to-water heat pumps. Feel free to laugh at my corny ass jokes. Probably the most asked question on the planet is, what are they, right? We're familiar with air-to-air heat pumps. We're familiar with ductless mini splits. We're familiar with conventional air conditioning unitary systems, right? But this is a slightly different breed and a mixture of all of those things. We get, hey, is this a heat pump or is it a chiller? Okay. Quite honestly, a heat pump is a chiller and a chiller is a heat pump as we see it. They can be used for either operation or purpose, heating or cooling. However, the deciding factor of what unit is right for you greatly depends on your geographic location and the unit's primary use. If your entire use is in the South and primarily used for cooling 98% of the year, then you're going to choose a unit that has better cooling performance at higher ambient temperatures. If your sole purpose for air-to-water heat pump usage is heating, right, at cold climate, in cold climates or high elevations, then you're going to choose one of our units that better supports heating temperatures and BTU delivery at colder ambience. And we're going to break that down for you as we shuffle through the presentation here today. Why do we use air-to-water heat pumps, right? So I haven't said it yet, and I may say it again, but an air-to-water heat pump is a really efficient, sexy electric boiler that sits outside, right? That's what it is. It heats up water, and oh, guess what? In a certain mode, it can cool it down. We're taking energy from the air, transferring that energy through the refrigeration circuit into a fluid, right? Generally and almost always a water and glycol mixture, right? But from there, we now have BTUs in pipes, BTUs hydronically. That's where the flexibility comes in. That's where the ease of zoning comes in. This mixture of the BTUs in the water, we carry more BTUs with physical size, right, through hydronic lines than we do through air. Air-to-water heat pumps can integrate with existing systems, whether that be solar, geothermal, or hydronic. Partial load capabilities, the ability to match partial loads with the air-to-water heat pump system is virtually unmatched. If you have a room that needs 500 BTUs or a room that needs 25,000 BTUs, the same system, when designed, piped, and pumped properly, can handle those two very different applications simultaneously. Super simple maintenance. We're not restricted on a lot of things with our monobloc design that we may be that may be restriction to us in the past, or with straight refrigerant type systems where we were worried about maximum line length of run for refrigerant lines and such. We'll also talk about dehumidification, right? So what is air conditioning? Air conditioning is basically the removing of the level of humidity and then cooling the air around it. You have to do both at the same time. If you do one before the other, you'll have two completely different effects. We're going to break this picture down, right? This is the picture that paints 1,000 words, if you will. We've got a complete system integration here where we have a heat pump outside, we have a buffer tank inside, right? Think of the heat pump as the charger, right? That sexy boiler that sits outside and does cooling. And then think of that buffer tank, you can see it just inside the basement there as the battery, right? We charge that battery up with either heated or chilled water. And from there, hydronically, we pump it throughout the house. Depending on the application, we may be pumping, definitely no humping, but we may be pumping chilled water to fan coil units for air conditioning, or we may be pumping heated water to floors and panel radiators for heating. We'll start breaking that down throughout the day. There's also two types of heat pumps, okay? There's a monobloc design heat pump and there's a split type heat pump. The most prevalent design in North America, and as it will continue to be, I believe, throughout all of eternity, is the monobloc design. This design and this unit arrives pre-charged and it is installed outside. It's then piped inside to the buffer tank and then onto the system. This requires no on-site refrigerant work. This also allows the ability to, as time and technology changes, to easily update technology. Now, as you know, right, we've been doing heat pumps since 2011, and one of the things that we pride ourselves on is, although the technology in our units change, evolve, and get far better with each iteration, right, we have very often projects that we're taking the latest of technology today and replacing units that may have been in service for 10 or 12 plus years, right? Just because, hey, guess what? This unit's so much more efficient than the unit that we had by updating the unit itself. This is hooking right back into all of the existing infrastructure. So a lot of good things can come from the acceptance of new technology moving forward. The other unit is a split type unit. Basically what this does is takes the water to refrigerant exchanger that's normally outside in a monobloc and moves it inside. This allows for area to be used in areas with a much colder ambient temperature. There are some limitations for line set length and such, and this one does require whatever your area requires for basic refrigerant knowledge, certifications, and evacuation processes. We'll talk a lot about monoblocs and a little about the splits coming up. So monoblocs, how do they work? This is just a nice colorful cutaway showing you that inside, it's not magic. We have a refrigerant to water exchanger. We have a DX compressor. We have a reversing valve, condenser fan, and evaporator coil. Right now, this unit is currently in heating mode, okay? It's taking the hot refrigerant gas, pumping it from the compressor into the water to refrigerant exchanger. The water from the building is pumped out to the unit and, in this case, heated up, okay? Generally speaking, I'm going to say this multiple times, so I'll start planting the seed now. We target a delta, a water delta, that's temperature differential from the inlet to outlet water ports of 10 degrees or less at maximum compressor capacity or system output, okay? So one of the things that we run into, these systems are super adaptable, right? And they're also super protective. And there are times when we may get a technical service call and say, hey, my system's not performing well. Well, the system is only going to be allowed to perform as well or to put out as many BTUs as the system or infrastructure design that's connected to it. So we're going to get into a lot more of that piping and pumping coming up. I just wanted to plant that 10-degree delta seed right in all of your minds. And if you ever do call technical service or you do start up your first air water heat pump or you're working on an air water heat pump, you will learn by the end of this what having below a 10-degree delta and above a 10-degree delta mean. So these units, depending on the unit, flow different volumes of water, and they come out of the building, in this instance, heating up and going back in. So 10-degree delta, we could be in heating mode, we're coming out maybe at 90 degrees. By the time we pass through the system, we're heading back into the house at approximately 100-degree water. Same unit, nothing changed except for the position of that reversing valve, right? So we've got that reversing valve there that is now in a different mode. And what that's doing is letting the cold refrigerant gas, okay, go through the exchanger. And the cold refrigerant gas then in turn cools the water down as it passes through, okay? Now keep this in mind. I'm going to plant another seed, antifreeze, right? We're going to talk about antifreeze quite often. What are the two things we have going on out here? We have water or a water glycol mixture going outside of the heated or conditioned space envelope of the house. And we have an exchanger that's got super cooled refrigerant on one side. The need for antifreeze in every single SpacePak air to water heat pump is mandatory, right? Mandatory from the fact that we say it is. If you choose not to use it, that would be on you. However, if you do not use antifreeze in a SpacePak air to water heat pump system and the lack of antifreeze results in equipment failure, a frozen heat exchanger, for example, it will compromise your warranty regardless of how cool you are and nice your installations are. We'll talk much more about that coming up. Efficiency, a little quick shot of efficiency here. Air to water heat pump, the quickest and easiest way to discuss efficiency in air to water is a COP. And think of COP as $1. And if I gave you $1 for energy and you gave me $1 worth of energy back, that's 100% efficient, right? I'm not wasting anything. So for instance, when we have units that have COPs in 3 and 4, is that I'm getting 3 and 4 times the amount of energy back than the investment of energy I'm putting in, right? So I'm getting far more BTUs out than I am kilowatts of power I am putting in to turn this unit on and get it to run. So the higher the COP, the more efficient the system is. Water temperatures, we generally do low temperature heating, okay? We'll talk about chilled water temperatures coming up as well, but primarily in heating applications, we target those low water temperatures, right? That 120 degrees. Some of our newer units are very capable of making those higher water temperatures up into the 140s and 145s, depending on your application. But with any application, okay, if your sole purpose in building your home or heating a home or cooling a home is to use the least amount of energy possible, right? So for instance, if I can design a house with an HVAC system or a heating system that will heat my house to set point on the coldest day of the year using 120 degree water, my system will be far more efficient and save energy than the same system using 140 degree water, right? The lower the temperature that you use, the less energy it takes to create that. And if I can heat my home with 120 degrees, again, it's going to be far more efficient than 140, okay? Think about it. I say this jokingly, but if there was a dragon in your basement breathing fire on a steel tub of water, right? And that dragon only needed to heat that tank up to 100 degrees, it's going to be more efficient than the dragon that needs to heat up to 140, right? The less energy used to create the same amount of BTUs needed to satisfy the load within the house is absolutely the way to go, right? That's why that load calculation is so incredibly important. We are far past the days of the old school boiler sizing and standing a certain amount away from your house and seeing how many fingers covers your house, and that's going to help decide how many sections your oil-fired boiler is. That's antiquated and stuff that we only use to joke about now. There's really true, clean, and precise ways to understand exactly what your load calculations and BTU distribution throughout the home should be. Will this work in my house? You know, the short answer is yes, but we'll go with probably, right? Because money cures all. You can put anything anywhere if you want to make it happen. But in a nutshell, whether it's a new construction or retrofit, these are some of the things you need to know. Right off the bat, a room by room load calculation. What are going to be the tasks of this unit? Are we looking for heating? Are we looking for cooling? Are we asking it to do some domestic hot water as well? What are the existing, if it's a retrofit, or desired, if it's new, forms of conditioning? Is there anything currently that we're tying into? All right. Is it air? Is it hydronics? Are there existing emitters, right? radiant? Is it baseboard? Are the fan coils, etc.? And then your target water temperature required to meet the load. Again, generally how this would go, once you decide what you want in a system, you back into the piece of equipment, right? You want to first design a system that uses the least amount of BTUs to heat or cool your home, okay? And that's done and started with design of the home, right? That's why you go to a home show, an energy show, and you see a lot of windows and insulation, right? Because again, even if you were burning $5 a gallon to oil, okay, if I updated my house and I burned half the amount of oil I did the previous year, that would be a much more efficient system, right? Not because we're burning less oil, but because we need less of it to heat the home, okay? Be aware of what climate zone you're in and whether we're doing single source electric or dual fuel. Those are all super important things. All of our reps across the country, again, you can find those through the rep locator at spacepak.com, and most all of our very helpful wholesale partners throughout the country as well can help you with all of these questions and setup. Let's get into a little bit more monobloc information. Monobloc design is super great, right? We're really only limited by one's ability to understand the dynamics of the unit, the amount of flow required, pressure drop, and so on to properly design the piping and pumping infrastructure needed, right? Here's a project. This is actually one of mine a very long time ago, probably about, I would have to say that those two units right there in that picture have serial numbers that have like the number 10 and 11 in them, right? They were very, very early on in the end of 2010, beginning of 2011, that doing air to water heat pumps here in North America. I was one of the lucky ones to start putting this equipment in the field. But basically what this shows you, although it's an older picture, the technology is still there, mounting these units 150 feet or so away from the home for aesthetics. Let's talk about our first in a line of air to water heat pumps. This is the Solstice Inverter Monobloc, or the SIM, right? This comes in two different sizes, a SIM 36, 3-ton capacity, and a SIM 5-ton, 5-ton capacity, right? SIM 60 is the 5-ton, SIM 36 is the 3. Both of these units are capable of heating, cooling, and domestic hot water. They both have cold climate cooling capabilities, which means they can make chilled water temperatures with ambient temperatures being in the single digits, right? Generally speaking, these can be used for cold climate cooling applications, right? We have one of these units, I think there's a picture coming up, setting on the building that we are in currently that we use for cooling server rooms in our building, right? And we're here in Western Mass, it gets cold, gets below zero a couple times, the units still are very capable of creating the chilled water temperatures needed, okay? These units deliver a wide variety of temperature ranges from 42 to 130 degrees. They both have notable and reliable, right, Mitsubishi inverter compressors. They're all, and every one of our pieces of equipment that we will discuss today have both variable speed fans and inverter driven variable speed compressors, okay? This allows the true load matching to pretty much any system, okay? The unit ramps up and ramps down based on variables within its computer program and PID control, allowing us to only, or the system to only use the energy needed to perform the function that it's doing, right? If I need 50,000 BTUs of heating, that unit will ramp itself up to a point where it's producing that 50,000 BTUs. If I need 20,000 BTUs, it would then ramp itself down to reach 20,000 BTUs. Okay, this is not a single stage boiler that's going to give you X amount of BTUs when I only need a very small portion of that. These units all come standard with freeze protection, ultra low amp draw, and they really truly do have super quiet operation. Here's a SIM 36 on our left in the photo and a SIM 60 on the right. You'll notice they're both up off the ground. That's super important. These are heat pumps, and when they're running in heat pump mode, I'd like to think that we're all fairly familiar with the defrost cycle in an air-to-air heat pump. Anytime these units are in heating mode, the outside coils are cold, okay? And if the outside coils are cold and the conditions are just right, be it damp, moist, rainy, snowy, whatever word you want to use, as the air gets moved across the coil, there's a tendency to build up ice on the coil because we are very, very cold outside. With that said, there are times these units go into defrost. They will do it automatically. What happens when that occurs is the unit just simply goes into heating mode for a very short, into cooling mode for a very short amount of time, generally 8 minutes or under, heats up the outside coil, melts all the ice off the unit, and then turns back in without anyone noticing. Unless you were outside to watch it happen, and then you would see unit melt, water melt off the back of these units quite rapidly. So elevating the units for proper drainage during defrost is paramount on all installations. All of our monobloc units, this SIM unit specifically, have user-friendly touchscreen controls. Okay, they come with the unit. Intelligent defrost, outdoor reset, Modbus compatible, and they can be remote mounted up to 600 feet away. There'll be a 65-foot cable that comes with them. If you choose to go longer, you're more than welcome to source your own shielded, very important there, shielded 5-wire cable to extend the 65-foot cable that's given with the unit. Again, we can go 600 feet away of the unit. So if remote mounting the unit is a requirement, we can definitely support that. A little breakdown information. I'm not going to split this up again. You're going to get this presentation so you can dissect this tomorrow. And then if there's anything you need more or have more questions on, you can ask your local representative or wholesale distribution channel. But basically, we look right here, the top BTU range in cooling. The SIM36 is capable of anywhere between 1 ton and a little under 3 tons of cooling. The SIM60 is that 17.8 up to a little over 60 or a little under 60,000 or a full 5 tons of cooling. Okay, this particular unit, to be clear, is our standard air to water heat pump. This is not a cold climate heat pump. You might look at the line that says, hey, we've got 70,000 BTUs, right? Well, yes, we have 70,000 BTUs at a certain ambient temperature. So similar to air heat pumps, as the ambient temperature gets colder, as the climate outside gets colder, right? The capacity on these units do change because we're getting energy out of the air. If there's less air temperature, there's less energy that we can capture from that. Right? And we'll see on a couple of charts here coming up. I'll bring attention to a couple different things. We go down to the sound, right? The sound portion of the thing and of the chart, and we've got 54 and 58 decibels. That's super duper duper quiet. Probably the most important thing on this whole chart, besides the amount of power required, which is just your standard single phase 240 volt circuit, okay, L1, L2, neutral and ground, we'll talk about that, is without a doubt the amount of flow. Okay, we're dealing with hydronics, and to move BTUs, we need to move flow. These units have an absolute minimum and rated flow. So the rated flow is either 7 or 13 gallons a minute. Okay, the absolute most concerns, problems, whatever you want to call them, with air to water heat pump system performance is based on inadequately piped and pumped systems. Period. End of story. Full stop. Mic drop. Whatever you guys want to say. If you don't move water, these units don't make the BTUs. Okay. We will daily get phone calls saying, hey, the unit's running, but it's not quite heating my tank up, or it's not quite cooling my tank down. And then we identify that they're just simply not flowing enough. These units are variable speed, as mentioned. They can run anywhere between 30 and 90 hertz, right? So the compressor will ramp up and ramp down. If I'm not moving enough water, there's no reason for that unit to ramp up because it's already meeting, right, its requirements, okay? Because it thinks, it doesn't know how many gallons a minute we're flowing. It doesn't measure that. It measures its temperature output, okay? And it adjusts the compressor speed and system output based on what its refrigerant circuit and temperatures are telling it. You will never, virtually never, get in trouble for flowing too much through these units, right? But very, 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 very much keep in mind our rated minimum flow capacities, right? 7 and 13 gallons a minute. Also pay attention to the tappings, 1 inch for the smaller unit, 1.25 inches. It's very much recommended that unit size dimension, whether it's inch or inch and a quarter, is used the entire length from the outside of the unit to the inside buffer tank. If by chance some of those lines or runs get longer, increasing the size to drop or to lessen the friction loss of the pipe is also a good idea. We'll talk about that later as well. Here's some charts. These are just based on pure water. Giving you these in a nutshell, again, you're going to get this information. The unit is a variable speed as mentioned, okay? This does not show compressor speed. However, what it does show is the BTUs available at the given temperatures, ambient temperature on the bottom, heating capacity on the left side axis there. So anything in the gray is what we're capable of. So if we wanted to just say, hey, how many BTUs will this unit do at 36 degrees Fahrenheit? Well, if we go up to the dotted line, that's the low end. It'll be a little over 10,000. If we continue going up to the solid line, right, that's a little over 25,000, and then anywhere in between. Similar with cooling. Everybody's seen charts similar to these and relatively easy to follow. On the heating side for the Sim60 or the 5-ton unit, understand these units you'll see, I had mentioned previously, oh, they do 130 degree water delivered, but you'll see here that the chart says 122 degrees. These particular units read on return water temperature, right? So if you set this unit for 122 degrees or 122 degrees, or 120 degrees, sorry, and you're flowing at an appropriate flow and the system is running properly, you're going to deliver that 128 to 130 degree water, okay? They run based off of return temperature, this particular unit does. So if you want 130 degree delivered water coming out of the supply going into that buffer tank, then you'd set the water temperature, the return water temperature at, in this case, 122 degrees. Ideally, everything else is working the way it should, pumping, flow, etc. I mentioned this is probably a slide you're going to get tired of seeing, but it doesn't make it any less important. We must always use some level of antifreeze in the system. Why is that? Because things freeze, right? We're using these units, they are setting outside, there is water going outside, so why would we not outside of the envelope into that unconditioned space? So we're going to condition it in some way, shape, or form. What we're trying to protect against is the freezing of that exchanger, right, or any other hydronic components in the outside unit. You might say, well, my boiler doesn't have antifreeze in it, or this doesn't have antifreeze, or what happens if the power goes out? Well, that's why we want antifreeze. But what we're trying to protect, okay, there's a couple of different scenarios here, and I'll try to make them kind of as simple as possible. The exchanger, as talked about in one of the first cutaway pictures, shows super cooled refrigerant on one side of an exchanger and water on the other side of an exchanger. If I'm looking to flow water at 10 plus gallons a minute and maintain a 10 degree delta, let's say I'm targeting cooling and I've got 50 degree water coming in and I'm going out at 40 degree water. For me to get a 10 degree delta, right, 10 degree drop across that coil pumping at 10 plus gallons a minute, how cold do you think the refrigerant side of that system has to be, or the refrigerant side of that exchanger? Pretty freaking cold, right? Like super cold, like well below zero. Like I know Jared is on here. We didn't mention him yet. He's our product manager / engineer. He was probably mouthing right now the exact temperature, refrigerant temperature would be. But let's just say, and don't quote me because I am not an engineer, that it's negative 32 degrees. If you have 10 gallons of pure water in an exchanger, right, going next to negative 32 degree refrigerant and the power goes out, right? How does an exchanger work? An exchanger takes a larger volume of water or a mixture of water and glycol, thins it out, right? Thinner water transfers temperature and energy quicker. The quicker we do that, the more efficient the unit is. So we have very vulnerable system here, right? If we have pure water and that system's running in cooling mode and the refrigerant is well below zero, who knows what could happen? Guy down the road bumps into the light pole because he's had too many White Claws, and all of a sudden the power flickers, unit shuts off, and flow stops immediately. Now you have pure water not moving next to a well below zero temperature surface, freezing is almost certain to occur, right? Some level of antifreeze is always 100% needed, okay? A lot of times it's geographical, right? We have both charts like this and charts via a map to suggest a base level of antifreeze. It is 100% the sole responsibility of the installing contractor to have the appropriate amount of antifreeze in the system. I will tell you that we, although not many, receive far more frozen heat exchanger warranty requests from southern and warm states because they feel, hey, I'm in cooling, nothing's going to freeze. That's where it happens the most, right? Somebody accidentally shuts the unit off while it's running, bam, you could freeze it, okay? Where a simple 10, 15% glycol, whether it's ethylene or propylene glycol mixture, will solve that problem indefinitely. Again, I'll say it because I have to. If your system freezes because of, basically for any reason, because it would be due to lack of antifreeze, then it is not going to be covered under the warranty. We will absolutely work with people. We're a very good company like that. Like I said, anybody who's had any questions or concerns with SpacePak in the past, I like to think that, they'd be very happy with our response and attentiveness to their problem. Here's just a different way of looking at things with the graph, right? Depending on where we are. See all the way down there in the southern end of Florida. I was in Miami last week or the week before, I can't remember, all these days run together, but even down there, we're looking at a 15% glycol mixture, right? Just a little bit of protection. Let's talk a little bit about the wiring. Although these air to water heat pumps, all of them, right, they maybe seem very advanced as far as their technology, and don't let me minimize that. They absolutely are. However, we do our best to make sure that you, as the contractor, the installing contractor, have to do as little as possible. Okay, still have to do it right, which is sometimes complicated, but still have to do it as little as possible, okay, to get the best outcome for your install. We want things to go smoothly. If they don't go smoothly, you're not going to want to buy another one. And quite frankly, that's not what we want, right? We're in the market to sell, produce, and sell and have installed quality HVAC equipment of the latest technology. We look at two major points here for the wiring. We've got power coming in, and we've got how we're going to basically our on-off switches. Line voltage, L1, L2, neutral and ground. Okay, the system circulator, right? The circulator that pumps the water from the buffer tank to the heat pump and back is controlled by the heat pump, okay, for freeze protection purposes and others. So that system needs a neutral. L1, L2, neutral, ground. L1, L2, neutral, ground. Period, end of story, all the time. From there, it's again relatively simple. We need just some low, no voltage, right? Smaller gauge wires. We're talking 18 gauge thermostat wire control wires that are basically going to tell this unit, hey, it's time to come on, and it's going to energize or de-energize the reversing valve that we talked about in one of the previous pictures. That just decides what direction that refrigerant flows in. Am I sending hot refrigerant gas to the exchanger, or am I saying cold refrigerant gas to the exchanger? Okay, so it's all relatively simple. And this is the things that also make changing out older systems, upgrading older systems with newer ones so much easy. They're so easy because we've used the same basic process for controlling these units from one to the other, regardless of the internal technology, of the advances in technology. Here's the basic piping, right? We kind of saw it blown up on that all-inclusive picture with all the bells and whistles on it. But this is it, guys. This is the buffer tank. That's the battery. The heat pump to the right in this picture is a SIM36. That's the charger. The pump, super important, right? Super important. You see the arrow on that pump? Pull out of the buffer tank, the lowest point of resistance, and push through the heat pump in every single case, which is the highest point of resistance, okay? Pressure drop. Want to make sure we have the pressure drop noted on these systems to help identify the exact circulator appropriate for these units, okay? 99.9 times out of 100, you will never be able to put a standard 1558, 007, 008, any whatever 00 green circulators are out there now on these systems. They have to be appropriately sized. Flow is of the essence, right? Flow is of the essence. If you have enough flow, okay, your system will work right. If you don't have enough flow, your system simply won't work right, right? The entire system performance revolves around flow. We need airflow as well, right? So when we set these units up, let's give them some room to breathe. They're air to water, right? Air to water, kind of a dead giveaway there that we need air flowing across these coils to pull that energy out of. And to do that, we need room to move that air, right? Outlet air in front of the unit, let's not block that off. Inlet air behind the unit, let's not block that off. And then some access air movement space to either side of the units. These are all spelled out really quite well in our installation diagrams and installation manuals. A couple of pictures. We have a SpacePak SIM036 here on the left picture, and a couple of 036 units on the right picture. Yeah, one of the Megan just poked her head over here and said, "Hey, this is what not to do." Anybody can see the difference between the two, the left and the right there. The left unit is up on blocks. The right units are not up on blocks, okay? Now, this is, I believe, in a southern climate, given the architecture of the building. Even in cooling mode, these units condensate outside because they're in cooling mode. Things are cold, right? So we want to make sure we give, whether it's condensate or even just plain old rainwater, right? We're going to give them an opportunity to drain through and out the bottom of the unit and not have a situation where we could catch things up inside. A couple other projects here, kind of cool jobs mounted on the walls, mounted on the ceilings. Look at that beautiful view on the right. Isn't that just magnificent? Sarcasm's free today, folks. A couple other projects where we've got multiple units together. We're going to talk about multiple units here. A photo from Lincoln, Nebraska, and then Lenox, Massachusetts. A company out of Lenox there worked with this project. We've got some, we can see some copper there on the walls. There's some very large HDPE type piping in the ground. It was about, picture on the right, the units were about 200 feet away from the home. It's pretty cool installation. This is another, actually, this is the top of the roof of the building that we're currently in right now. The picture on the left shows the old or previous earliest version. I hate saying old, right, because I'm old, but the previous version of the very first air-to-water heat pump we offered in North America, the SCM060. That is what is replaced with that is what you can see here on the right. That would be the new inverter SIM060 version. This is the unit that we use for our low ambient cooling. Okay. A couple other cool pictures. I like showing some of these pictures because it's important to see these kind of things in their real world habitat, right? They're not fictional. This is not a new idea. There are thousands and thousands of SpacePak air-to-water heat pumps installed all throughout the country. Whether it be California, Massachusetts, everywhere and anywhere in between. Kind of cool. Next up, right, we spoke about our SIM series of monobloc heat pumps. We're going to talk about our ILAHP series, right? So kind of a little word jumble there, but basically this is the first of our low ambient or cold climate models, right? These units, this particular unit is a unit that's designed to deliver high BTUs at low ambient temperatures, okay? Different type of compressor, Toshiba, inverter-driven fans, however, and compressor, all inverter-driven, freeze protection, low amp draw, quiet operation. And obviously we've got our buzzword of the zero ozone depletion R410A, which now isn't good enough for the government, so we'll be changing refrigerants, which we'll talk about here coming up, to ones with a lower global warming potential. Similar to other, all of our SIM series heat pumps, and R410 model heat pumps, we have touchscreen controls for them. All of the same rules apply that we've discussed in the past. 600 feet away, user-friendly. One of the things I like about these controls, right, everybody's got some kind of touchscreen device, whether it be an iPad, iPhone, Android phone, if you're cool, or anything else that's available today. But we're familiar with how this type of technology works, right? It's not like those old advanced controls on boilers. I'll leave the Blue Boiler Company name out of it, but geez, you had 4 buttons to the left, 3 buttons to the top, and then you have to go through some kind of hieroglyphic decoder ring to figure out what they say. These charts, parameter settings, things of that nature on these controls are very intuitive, very easy to understand, written out in full and very clean English. This particular unit, let's take a look at it, right? Anywhere from 24,000 BTUs of cooling up to a little over 5 tons. And in cooling and heating range, anywhere from 15,000 BTUs upwards of 63,000 BTUs of heating, right? Now this unit has a range that goes all the way down to negative 22 degrees Fahrenheit, where the units we looked at previously, although they'll run below 0, they really start to drop capacity off after about 5 degrees above. This unit adds a whole lot more range of capability to your system based on your geographic area. Okay, again, let's take a look at a couple of these things. Super important. How many gallons a minute? 12, right? What's our power going in? Single phase 240. Our decibel rating is very low. The other thing I didn't mention, but we want to be super aware of, is our pressure drop, right? The pressure drop, when added to all the pipe valves and fittings, is going to let us know and help us decide what exactly size pump and piping we need to use to get proper operation and capacity out of these systems. Little breakdown here. You can see, and again, anywhere in the shaded area is a capacity that can be reached by this unit. You'll see if we look down into the negative 20s, there's a relatively narrow band of capacity. That's basically because the system needs, when it gets super cold, to have a minimum run capacity, right? So it ramps up and it may be running at 50, 60, or 70 hertz instead of a minimum of 30 if the temperature was warmer. And very similar when we're in heating mode, when we get up much higher in temperature, like 50 degrees and above, it may automatically ramp itself down in a way to protect itself against too much excessive amp draw. So same thing on the wiring, guys, right? This might look a little ominous, like, oh shit, what's going on here? But it's really quite super basic. We have our L1, L2 neutral and ground coming in, right? Our power. We have our multiple stages available. These are output terminals. We have alarms. The controlling of the circulation pump, L1, L2 neutral and ground. This particular unit affords us the ability to use either a 110 volt or a 220 volt pump, depending on what you have available. Remote on off, remote heat cool on off. Those are basically our enable switches, right? We're enabling the unit to be on, we're enabling it to be heating mode, we're enabling it to be in cooling mode. One thing that I didn't mention, and I will mention it, and I'll mention it very clearly, is those terminals are 110% no voltage terminals, right? You look in the upper right-hand corner of this slide, it says caution, the remote on off, remote heat cool on off, and DHW enable inputs are voltage-free relay contacts only, and any voltage introduced to the control at these points will immediately destroy the primary unit control. What does that say? Don't put any friggin' voltage to them. Not 1 volt, not 24 volts, not 8. Don't put any, right? They produce their own 3 volt DC. They're basically looking to return that voltage of their own back to their circuit, right? They create a loop. It's a jumper. It's a light switch. That's the only thing that should be connected, right? An aquastat output terminal that does not have any voltage. That's the type of contact we're doing here. I will tell you, and we know this from experience, right? If you put 24 volts there, you will destroy the main control board. If you do it again, you will destroy the second main control board. If you continue to do it, beyond us suggesting that you don't, you will still continue to destroy the main control boards until you realize to just read the caution at the top of the slide, okay? I'm not trying to make light of it. It's a real big pain in the ass when people don't read. I don't read sometimes, but I can promise you this is something that I do read, and I want everyone to be super, super duper aware of it, right? We have many different options for controlling these units. They could be our SSIC SpacePak system interface control. It can be a standard aquastat. It can be a dry contact aquastat. It could be a Ranco aquastat. It could be some version of a Honeywell aquastat, right? Just don't put voltage to these terminals, please. Oh yeah, don't forget your glycol protection in this unit as well. Here we go again with that same slide, right? Again, folks are going to get this in an email tomorrow. I don't believe my voice will be connected, at least I hope not. But with that said, you'll have the pictures to reference. A couple of ILAHP or low ambient installations under a deck here on the left, outside on a Solstice stand. These stands we offer, they're in the price book, getting units up off the ground for drainage. Got some Northern California installations, Cambridge, Massachusetts here, and so on. Upstate New York's beautiful shipping container home. We have this project that was on one of our home screens. It was a huge Basilica Hudson project. I think it was 5, 6, 7, 10,000, something like that, square feet of hydronic radiant in the slab here, run by those heat pumps. And those funny looking things on the end are just there for dramatic effect. Let's talk a little bit about the split, right? The split is our other cold climate offering. Again, this unit is different than a monobloc because the refrigerant to water exchanger is inside as compared to being outside, and they're connected with a refrigerant line set, okay? No more than 35 feet, okay? Simple piping, very similar to wall hung boilers. Reliable Panasonic vapor injection compressors for higher capacities at low ambient temperatures. Again, freeze protection and ultra quiet operation. Take a peek at this unit. This particular unit needs a couple different electrical services, one going to the outside, one coming to the inside. Take a look at pressure drop as well, gallons a minute flow rate, and so on. This unit too needs antifreeze, right? Because guess what? Even though we may be using it for heating, okay, we can use it for cooling, but what happens in heating and the unit goes into defrost? The unit temporarily goes into cooling, right? It just simply does, right? It's a short amount of time, but it still happens. And if somebody haphazardly shuts the unit off or Mother Nature decides it's time to turn the lights out or drop a tree on your house, although that may be the least of your problems, we don't want anything else to freeze. Wiring for this unit, the outdoor unit wires different and separate from the inside. The indoor module requires the first leg, second leg, and neutral, right? L1, L2, neutral, ground, right? Circulators controlled by that. The outdoor module does not control the circulator itself. So from there, it could just be the normal 220 with a ground. So L1, L2, and ground. There's the communication cable that comes with the system, okay, and the 35-foot line set and all of that stuff is included. Also the same with this outdoor module, there's your remote on off and your remote cool, no voltage control contacts. Pretty cool. Just keep all of this stuff in mind. Here's the piping, right? Very similar to the monobloc. Once you get inside, hey, that kind of looks like a wall hung boiler, and it probably could be if those lines going from the outside unit to the inside unit were not just standard refrigerant lines. So again, when you buy this unit, we will ship the inside unit, the outside unit, the 35-foot line set, and the control wire, okay? That control wire that goes between the inside and outside unit. Please understand that these units are refrigerant based units, and all standard refrigeration protocols will need to be used in the commissioning and startup and proper installation of this unit, right? That's evacuation and drawdown and weighing and refrigerant and so on. These particular units come standard, right? You're going to read this in the book because anybody that puts one of these in is going to be nice and read the book prior to the install. I know they are. But by chance you missed this part, The units themselves are shipped with enough refrigerant for 16 feet of line set. If you have less than 16 feet of line set between the inside and outside unit, congratulations, you don't have to do anything besides vacuuming the system down, holding micron levels, and using standard refrigeration installation practices. However, if you have line set that's over 16 feet, remember it comes with a 35-foot line set, you will have to weigh in refrigerant, right? And we have a chart in the manual that you're going to read that draws that out pretty darn clearly. But from there on the inside, this is nothing we haven't seen before. Drawing out of the buffer tank, pumping through, pushing through the indoor unit, the higher resistance of the exchanger, and then back into the buffer tank to either heat or cool that tank. Right, everybody needs a little space sometimes. So let's give our unit some space outside, whether that be behind, in front, or to either side to allow for servicing and proper airflow. Here's an SIS installation in kind of northern New York area. Good friend of SpacePak here, as you can imagine. And also looks like good friend of Grundfos pumps and copper. But with that said, we look at this SIS indoor unit on the left, kind of looks like a wall hung boiler, right? That's what it's resembling, except we have refrigerant lines coming underneath it instead of gas lines. Okay, those pipes come out the bottom, up, over, and around into the buffer tank. And from there, that tank is either heated up or chilled down. So super good insulation, clean and neat. We'll talk about this more coming up. I'm sure there'll be a slide or two at the end that allows us to kind of let you know how to contact us via social media and such. We want to see pictures, right? We love seeing pictures. If your pictures are cool, we can send you things, right? If it's super cool, you can get like SpacePak hat, socks, underwear, things like that. You would wear proudly, I'm sure. A couple other SpacePak SIS installations, SpacePak Inverter Split, as it's dubbed. This is a high elevation application in Colorado. Okay, just to cool, tuck the unit high up in this side core port, ran the refrigerant lines inside, and here we have, it's obviously still under construction, but good just the same. A couple of units here in Killington, Vermont, installed outside, 2 split units here. Similarly, we have some units setting outside and pipe going inside to that inside buffer tank. I'm sorry, inside SIS indoor unit, which houses the controls and the exchanger. Another project was out in Nevada, Tahoe, Truckee, California area. Cool project, crawl space, small house, small load. This is one of those places that gets, 19 feet of snow and everybody else gets a dusting. So things get mounted underneath decks, porches, patios, and things like that to offer cover. Another project here, just a couple cool ones to see flexibility and such. Again, you can see these units up on stands to allow for proper defrost runoff and condensation runoff. Another project here, we'll just keep right on it going. Next step up, right, in our 410 offering is our commercial heat pump. So although you can take our smaller heat pumps and start to put them together, and many people have, we've got some heat pump projects with 25 small 25 5-ton units on it, right? It's a great way to offer truly flexible capabilities and offer a super efficient system, right? Only using the amount of energy needed. Now, if you're consistently needing larger volumes of energy, larger capacities, right? We offer a commercial air to water heat pump. Not nearly as sexy looking, I gotta say, but it sure does put out heating and cooling energy, right? Delivers up to 140-degree water temperature, has 2 variable speed compressors in it. Okay, this is commercial application. The thing to note here on the unit, this is a 3-phase 460 unit. That's something to be aware of. It's not always available in certain areas, or some kind of transformer upgrade may need to be used. But generally, if we're in a situation, a commercial application, not necessarily residential, but in a commercial application where we start needing 4 or 5 heat pumps, this starts to become a potentially viable option, right? Even on a residential application, it could be, because as with the other heat pumps, we can remote mount these things, right? As long as we can run supply and return hydronic piping underground, below grade, we can go hundreds and hundreds of feet away from the home. So we could put this thing a very non-impinging distance away from the home. Just another look at it. Special design, low ambient temperatures. This is another unit that will produce heating BTUs at really low ambience, down into the -20s. Multiple units for decarbonization and electrification solution, right? So that's really where we're pushing it, right? There's a lot of people in the country, I'm totally not going to get on my soapbox right now, but well, we need to push green energy, we need to do this, we need to save, we need to, basically the way I look at things, I try to keep it simple. We want to offer you a piece of equipment that is the most efficient piece of equipment that we can offer. In some instances, you could run your entire house on a heat pump, okay? Because that's the most efficient way. In some instances, you can't. In some instances, there needs to be a combination, right, due to your climate or your load, where we might want to do a heat pump and we might want to bring on some backup heat, right? These units are infinitely flexible when designed appropriately, right? So let's just keep all of that in mind. We're not trying to shove down anybody's throat anything but options and efficiency. So what's coming up, right? I mean, who doesn't know that the government, the beautiful government of ours, is looking to change refrigerants, right? Anybody that's been in the industry long enough can likely remember the R22 to R410A change. Well, now we're changing from R410A. Certain areas of the country, California, have already made that shift, right? And to accommodate that shift, we are currently shipping, currently offering our newest line of monobloc air-to-water heat pumps, the R32 series. We use R32 refrigerant. The need for refrigerant, as described by, did I say our beautiful government? Yeah, our beautiful government, is that we need to use a refrigerant that has a lower GWP, or global warming potential, right? So it has to be below 675, I believe. Has to be below 700. And I believe we click in there at just under 700 with the R32 refrigerant. So our R32 series of heat pumps, okay, come in 3 different sizes, all right? They are all a cold climate design, okay? And again, just like the others, simple, advanced, and easily flexible for all of your applications. We've got cooling capacities on the smaller unit of up to 1.5 tons, the middle unit up to 3 tons, and the upper larger unit a little over 4 tons. And then heating capacity, very similar, right? Maximum of 22,000 BTUs, a little over 40,000 for the 40 unit, and up over 70,000 BTUs capacity for the large unit. These units are very capable of reaching and surpassing that 140-degree delivered water temperature. Here's the switch, right? The graph, we probably should have led with this one. Maybe we'll switch it around next time. R32, 675, right? GWP, R410A, 2,088. Thank you, government. We need to change our refrigerants. Although this is a mandatory shift, okay, unless things change the way we understand it and it is written, any units using 410A refrigerant are still very much high-end, top-of-the-line units, and can be sold very easily throughout the rest of this year and all of next, as we transition to through this transition period of from one refrigerant to the next. Here's a little breakdown on the 3 different sizes. Again, probably one of the coolest notes about this that are not on this slide, unfortunately, is the much lower pressure drop on these units than on previous units, okay? So essentially, to get the proper amount of flow required, you can actually get away with using a smaller, more energy efficient circulator, right? Smaller circulator also equals a lower cost circulator, okay? These are also all single phase 208, 230 units. Please be aware of capacities, ranges, flow rates, and things like that. Again, your rep or local distribution can help walk you through any questions you may have with proper sizing, which always begins with a proper load calculation. Oh, hey, there was two slides. Guess I made a mistake. This is the slide that shows the magic, right? We go down to the sound. It's highlighted there on the left, followed across 41, 43, 46 decibels. Excuse me. These things are whisper quiet, okay? Absolutely whisper quiet. Hydronic, we go down, we've got water temperatures in the 140s, 1-inch tappings. The big thing here, look at the pressure drops, right? Rated pressure drops, very, very low compared to some of the equipment we've seen previously. This just allows us the opportunity to have, again, much more flexibility with our piping and pumping options. Panasonic compressors, variable speed, fans and compressors in all three of these units. Super excited. We have some of these out about being installed and operational, super quiet, super efficient units. Pretty interesting stuff. Wiring, okay, again, might look like something hot and heavy, but I can promise you it's very much similar to everything we've seen in the past. High voltage wires come in, could be anywhere between 208 and 230 volts, L1, L2, neutral and ground, okay? It's important to note that 208, these units are compatible with the use of 208 voltage, right? That's another bonus of these units, okay? Remote heat cool, remote on off, DHW on off, heat cool on off, and so on. What does that tell you, right? Hey, caution, the remote on off, remote heat cool on off, and DHW enable inputs are for voltage free contact relays only, right? We're not gonna add any voltage to those. Otherwise, what's gonna happen, we could break some stuff, and then we're very likely, if not guaranteed, to not give you a warranty because we're warning you so many times. The touchscreen display looks a little different on these units compared to our 410A version, okay? Just as cool, probably a little fancier, just as easy to use. Allows you to do time, curves, smart grid connections, electric heaters, easy to access fault codes if anything were to ever happen. So super easy to use and intuitive touchscreen controls for these units as well. We'll do a quick breakdown so we don't get lost in too many charts here. However, here's the CC3218, so this is the smaller ton and a half unit. Again, we see these graphs. The lower dotted line is the base capacity based on the lowest compressor speed, right? So 30 hertz, right? The lowest turn down of the unit. And the red line in this slide being the highest turn up, if you will, of the unit, right? So anywhere in the middle, you draw a couple of lines on these charts and you'll be able to see based on your design temperature, how many BTUs this unit could handle. And then you can see again, the range of COP or efficiency also changes as temperatures get higher and the compressor itself ranges up and down, right, in capacity. Cooling performance, the same. I'm not going to dwell on these too much again. These are also can be found right now today, but not this moment, on SpacePak.com's literature tab in their website when you download the installation manuals and submittal sheets. The middle unit, CC32-40, heating performance. This is just 120 degree delivered water temp. Again, a great range of capacity and efficiency. Cooling, heating, again, a great range of heating capacity and heating efficiency. Cooling as well, right? Coming soon, okay, all of the CC32 units have the ability to link to what we call a warm link app that allows us to remotely see kind of what the unit's doing. This is very much a service tool and not, I repeat, not intended to be used by end users, right? Not to be used by the homeowner. This is not a, hey, I need to turn my heat up or down, I'm going to use this. This is a service tool, right? This is a service tool that will allow the contractor, the installing contractor, to look at the system to identify if there is how it's running, if there's something that needs to be addressed, or if it's just happy, right? Think about it this way. If maybe there's an install and the customer calls you the contractor, assuming that everyone on here is a contractor. Hey, my system's not working. Okay, well, I have you registered in the app. I'm going to turn it on. You open the app, you can see that the Joneses unit is running perfectly fine. You then go back to the Joneses on the phone and say, hey, what's not happening, right? Oh, well, little Joey's room's not getting hot, or little Joey's room's not getting cold. Okay, well, that's certainly better than running all the way out there and thinking or preparing for something that's not actually happening, right? Knowing that it's not a heat pump related concern, and maybe it's more of an infrastructure, or hey, no batteries, or the batteries are dead in the thermostat concern, that's on a contractor point. That's going to help you decide who you're going to send to the job, right? It's certainly going to be able to do that. The other benefit to this is, say you are on a job, say you're doing commissioning, say you have a question about parameter settings or defrost controls or so on. You can log into this unit. You can call SpacePak technical support. We can log into this unit. We can see exactly what is going on simultaneously, right? This isn't a fully launched project yet, or a product yet, right? But it is currently available on all units. So anything that we do as far as complete usage is in its infant stages at the moment, right? We've used it quite a bit around the country. It works great. I use it at my house. If I was in person right now, I'd turn my phone open here and I would show you what my unit's currently doing, if it's calling for cooling or not. At least I hope it is. So a couple of pictures of an install. This, I believe, was up in the Pacific Northwest. A couple of 4-ton units here. And then what does the future hold, right? I was hoping there's a question slide coming up because I'm starting to lose my voice here, but high temperature, cold climate, air to water heat pump. What's the future, right? If anybody went to the HRI show this past year in, where the heck was it? Chicago, beautiful, the Windy City, Chicago. We actually had an R290 teaser unit out there, R290, AKA propane refrigerant, right, has a GWP of 3, which is obviously much lower than R32 and very likely to where the government will be pushing in years to come. I'm going to limit my conversation regarding people's understanding of R290. Only know that R290 refrigerant and R290 based heat pump capable of delivering much higher water temperatures to help encompass the home's true largest heating load, which is your domestic hot water load. We will currently are working on, and will have when the time is right, absolute solutions for higher temperature air to water heat pumps. So we're going to maintain doing the best we can to stay ahead of the market, in the market, with the market, offering the best and most advanced equipment available. Oh, look, there it is, Chicago, R290 unit. Pretty cool. Yeah, it looks just like the R32 unit setting to the left. Physically in the box, they're the same. However, the refrigerant capacities and a couple of other things are slightly different. All right, I'm going to pause for a second. Don't go anywhere. I'm going to touch base here with my team super quick and see if there's any questions that have come up. I just fed a lot of information about our equipment. The next section is going to be breaking it down on how to apply it, right? Piping, pumping, orientation, configuration, and things of that nature. So if you need a quick sip of something, take a quick break. I'm going to pause for a moment and we'll be right back with you. Quite a few questions popped up about the R290. So I went back a couple of slides here. Listen, the answers, although are not skewed, it's very likely, because we are behind in the market, so to speak, with some of the newer technologies compared to Europe, the European markets. The current bottom paragraph, left side of this slide, the current international standards already allow for the safe use of A3 refrigerants and similar outdoor equipment. Basically, those R290 charge to the right, the 0.85 kilograms or the 0.87 pounds, those are international standards and very likely what we will adopt moving forward. Okay, just this is meant to be a teaser slide. If you ask us 500 questions about it, we could probably answer 2 of them, right? Not willing or able to disclose too much information about this. Only know that SpacePak as a company continues to look to the future and always being ready to offer equipment as needs, efficiencies, and expectations change. All right, let's go. Emitters are the next one. I'm not sure how we're doing on time, but we're probably about halfway through or a little bit more. Emitters, right? What are the emitters? Emitters are what's going to take the energy that we've created and store it in the buffer tank and put it in your space, right? The emitter could be the fan coil. The emitter could be the radiant floor. The emitter. Ooh, that was a terrible word. If the emitter could be a low temperature panel radiator, it could be a higher temperature piece of baseboard. It could be low temperature baseboard, right? And anywhere in between. So we have some additional equipment here at SpacePak, right, to accompany our air to water heat pumps on their journey to efficiency, right, and satisfying your home's loads, whether that be hydronic fan coils and air handlers. We have stainless steel buffer tanks with built-in electric backup, and on the horizon, right, a hybrid domestic hot water indirect tank. Those are things we'll break down here in the next section. Here's a distribution example, not quite as cluttered, if you will, right? Politely cluttered as the picture we saw earlier, but this is basic system. Heat pump outside, buffer tank inside, battery inside, thermal storage inside, that's that battery. The battery is the thermal storage is the thermal battery. Outside is the charger. That's what we're gonna do. We're gonna heat it up, we're gonna cool it down. And then from there, depending on what we're doing, we're sending either heated or chilled water throughout the system, plain and simple as that. The SpacePak small duct air handler, something that some may be familiar with. We sell many thousands of small duct high velocity air distribution systems every year. And we continue to do. That's really the true bread and butter of SpacePak. These units we do have available in hydronic models, right? So super cool for us to see hydronic air handlers. As you can see, the SpacePak small duct high velocity air distribution system sets up similar to this picture, a main duct with smaller 2-inch runs distributing the conditioned air. We have variable speed fans in the air handlers as well, controlled by our advanced control board, monitoring static pressures, choosing different speeds for different modes. Super adaptable. If you're interested in learning more about that, information can be found at spacepak.com. Also, the training tab, where maybe most of you signed up for this presentation today that you're just loving, okay? In the future will be future trainings, right? Other trainings, and one of those will absolutely be the small duct high velocity training coming up. Little breakdown on the 3 different sizes of our air handlers, anywhere from 2 ton up to 5 ton and everywhere in between. Pressure drop and capacities based on water temperature and flow rate. Okay, all this stuff is available on our submittals and manuals. We also have available to you what we call our Highwall, right? It's a hydronic fan coil unit. Sure, it looks like a mini split head. Okay, it's not the sexiest thing in the world, but if you want to add heating or cooling to a space and you don't have the room and you already have a hydronic system or you're using an air to water heat pump, these aren't refrigerant lines connecting this thing, right? These are hydronic lines. They're available in 3 different sizes and can deliver up to a ton of cooling or over 25,000 BTUs worth of heating, okay? Super quiet operation. Again, I want to be explicitly clear that these units are not the ultra advanced ductless split units that are out on the market today. This is a very purpose-built utilitarian type unit. You want to add cooling to a space, you want to add heating to a space, you want to do it with the least amount of effort and use a remote to turn it on and off. This is the unit for you. You can see a couple of installations here installed in different homes. We also have a Thinwall hydronic low temperature fan coil. Again, these are low temperature emitters, right, which fit right into the portfolio offering of our air to water heat pumps, which are the low temperature experts, right? This again is a hydronic base unit. There's no refrigerant, super quiet, right? Think of this as just a fan assisted panel radiator or fan convector, right? Coil, it brings air in the bottom. A barrel fan on the bottom blows air out the top. Again, these are available in multiple sizes, okay? Again, it's not a super fancy unit. This can be connected to a wall thermostat. However, the wall thermostat will only handle the turning on and off of the unit. It will not handle the switching from heat to cool. Here's a couple of pictures of what they may look like. The unit on the right is pretty cool. And I say that because you're like, hey, what's that ugly ass thing dangling down there on the right? That's actually the condensate drain. If we're using these for cooling, remember, all right, we have to have a place for the cooling to go. So granted, I think what they ended up doing with this particular unit is the person who did the trim there, they built a little chase to box in that, but we were able to take this picture prior to it. And I like it because of that. Just allows you to understand that there's going to be a couple other considerations when installing these. But listen, if you're putting in a ductless mini split air-to-air style from any of the major companies or brands, or even some of the shitty ones you see on social media, they're all going to have to get rid of their condensate someplace else. I mentioned we have stands. We have heat pump stands. Basically, this just allows us to get our heat pump a safe distance off the ground to allow for proper defrost and condensate runoff. We also have some stainless steel buffer tanks. Now, stainless steel buffer tanks are the second most important part. Some may offer or suggest it's the most important part of the system. This is where all of the energy is stored before it leaves to go out to the system. We have currently 4 different sizes of buffer tanks with a larger one on the way. So we'll be covering from 13 gallons up to 119 gallons. These are empty, wide open, 4-pipe buffer tanks. They are empty tanks. They are made for thermal storage and hydraulic separation. We'll talk about hydraulic separation coming up. They are stainless steel and they come standard. That's right, edge of your seat here, standard 10-year warranty, okay? These are a great option, not only for SpacePak installs, but anywhere that you need hydraulic separation, thermal storage, and even some electric backup. The 3 larger size units offer their own built-in standard 2-3 kW elements, allowing us to offer upwards of 20,000 BTUs or something like that of boost heat. Let's remember, here's the buffer tank. This is our thermal storage. Our heat pump goes outside. Oh, hey, look at that in the bottom left-hand corner of the diagram. There's our circulator drawing out of the buffer tank, the low pressure part, pushing through and into the heat pump, right, which is somehow hidden in that cloud of snow, and push through there, coming back hot, right? That's one loop, and then your heating load is on the other side. The 4-pipe buffer tank allows for true hydraulic separation, allowing the heat pump, which may have and would likely does have a higher GPM flow rate. In this case, we're talking 12 gallons a minute on the left side of the tank. Maybe a small load is calling on the right side of the tank, 1 gallon a minute. They can run in perfect harmony without influencing each other, right? That's where that hydraulic separation comes into play. How do we size buffer tanks? Okay, sizing buffer tanks relatively simple. Okay, I could tell you that a buffer tank is never too big, and that's kind of true, because although these units are extremely efficient, okay? There's 2 points in time that they are the most efficient. Anybody know what those are? Crickets, crickets, crickets. Okay, I'll answer. It's when they're off and when they're on, right? That's when they're the most efficient. These units are not meant to turn on and off and on and off and on and off and on and off, right? Efficiency comes from a long, methodical, right, runtime. We want these units to come on, ramp up to their desired capacity based on set point, based on ambient temperature, based on their loads, and run there consistently until that load is satisfied, right? Similar to cruise control, right? Your car is generally going to be more efficient in cruise control than it is if you're just mashing the pedal up and down to get over hills, okay, or to pass someone or so on. Now, bigger's better. Yep, I said it, okay, changed my mind. But regardless, if we want to break it down into more of the numbers, here we go. The buffer system volume, buffer tank or system volume, must be equal to or greater than 7.5 gallons per nominal ton of the unit's capacity at its lowest turn down. For example, if the unit's lowest turn down or minimum capacity is 20,000 BTUs, then if we did that and we took into account our 7.5 gallons per ton per nominal, or 7.5 gallons per nominal ton of the lowest turn down, we know that we could get away with a 13-gallon buffer tank. Now, that's the smallest it should go. We need to have a minimum amount of buffer storage because we don't want these units to short cycle, right? We want them to come on. We want the compressor to heat up. We want everything to move as appropriate, all right? And we certainly also have, believe it could be somewhere around a minute or two minimum runtime, right? These units want to run, right? We want to let them run, okay? Remember also to consider the system's capacity. And in a situation where there's a large volume, all right, perhaps a large slab or a large radiator, monoflow radiator system, you may want a larger buffer tank. For example, if I had 100, I don't know, let me change, 100 by 100 square foot radiant slab, one zone, okay? Now, although the load may be small, if all of that water, the water glycol comes running back to that buffer tank, if that buffer tank is too small, it'll turn that buffer tank inside out. And then when the heat pump comes on, it has an uphill battle the whole way, right? We want to have the buffer tank volume so that it's greater than the system volume, so that there's never a situation where, hey, the system calls and all of a sudden, again, hypothetically, it turns upside down, the temperature in the tank, and now the heat pump is an uphill battle. The next thing in our line that we're working diligently to bring to the market, and very well may have some beta units landing here end of third quarter, beginning of fourth quarter, is a dual buffer tank / domestic hot water option, okay? Basically, the volume of water will act very much the same as our 4-buffer tank does now. There'll be a potable water coil inside of it. That's not where the volume will be. It'll be like think about it like an on-demand style water heater. Potable water will come in. It will get a temperature rise depending on the temperature in the buffer tank. And from there, depending on that temperature rise, it could go to a secondary source to boost the heat up a little bit more before it goes to your faucet, or depending on the draw and or buffer tank temperature, it might come right out of the top at 120 degrees, okay? Super cool. It's gonna have multiple ports. It's going to have multiple extra electric elements that can be controlled both by the heat pump and by some external PV source. So super versatile tank. Looking very much forward to bringing that to the market in the coming months. Installation and layout. I'm going to pause myself for a second here just to check with the team and make sure there's no other questions that popped up. So bear with us here for a moment. All right, I'm back. Installation and layout, right? Let's start dealing into a couple. Let's see some piping diagrams. Let's see some wiring. Well, maybe we'll stick away from the wiring. We'll stick to the hydronic side of it. Basically, these units, again, They're super simple. You power them. You can turn these things on with a light switch, right? Where we really need to focus, and we focus on this because we base this on the amount of inquiries, concerns, tech calls, and so on that we get in the market as to where and how we help shift, right, the topics and the length of time we spend on topics in these trainings. These units all have horizontal discharge. Let's make sure that they have room to move the air, right? We talked about that on some of the other slides. A couple of examples, even though these units are underneath the deck, the air can still move up, in, around, and through them, right? Let's keep that in mind. Airflow is your friend. Let's not do what we have X'd out here and blow the hot or cold air from one unit into the back of another. This could affect one of the two or both systems' performance. Potential airflow and a piping complications on this one. I'm not going to dig into it. This is horrendous, this particular project. I'll leave it to your imagination. One of the things you know, don't be afraid to take pictures of your equipment. Don't be afraid to ask questions, right? I would certainly prefer, and so would our manufacturers representatives, your inside and outside sales folks at your wholesale distributors, ask those questions, right, before it becomes a problem. Nobody wants to deal with a problem, even if it may seem like a silly question, and maybe you get your chops busted because we already said it 7 times during the training today. I would still rather say it 8 times than have you accidentally do something wrong when you're not intending to, right? You're looking to install a good, clean operating system, and that's all we want as well. So don't hesitate to ask questions. I know there's some questions flying into our chat lines, I guess, for lack of a better term. That's what I'll call them. Eric, Meagan, and Jared are all on top of answering those. Multi-unit examples, some really cool examples of this stuff, past, present, and future. So here's the basics. We have your heat pump outside, and we have your buffer tank, okay? This particular application is filled, this isn't filled 30% propylene, glycol, antifreeze, right? Buffer tanks provide the location for hydraulic separation. This way, as mentioned on a couple slides previous, we could have 12, 13, 14 gallons a minute flowing on one side of the tank and a half a gallon flowing on the other, right? And they'll work together. Looks like we're going to hit this slide again because it's so important. I will skip over it. Sorry for having the slide in here again as well, but we're keeping it simple on the buffer tank, right? 7.5 gallons per ton of the unit's capacity at slowest turn down. And generally speaking, again, they're most efficient when the system's on or system's off. So to optimize those 2 times, right, on time and off time, we use larger buffer tanks where we can. When we're designing piping, pumping, and applications, we're really much looking at everything. The pressure drop in the heat pump itself, the pressure drop in the pipes, valves, and fittings. There was a project was involved with that shall remain nameless in a territory that does a lot of air-to-water heat pumps. And we were like, hey, you know, doesn't sound like you have enough flow. Oh, we have this pump, we have that pump, we're doing everything right, and we're only 15 feet away, and so on and so forth. Come to find out, it was like 17 elbows in the system, right? So each one of those elbows added a level of pressure drop to the system that basically just compounded the amount of overall system pressure drop, and he didn't have enough flow because of that. So when you talk to your rep, if you ever have any questions, when you talk to your distribution, if you ever talk to tech service, keeping this simple is the absolute best way to be sure of the system's performance and getting the most efficient system out of your install. Any questions on those? So the team is keeping up nice and tidy with questions that are coming in. Appreciate the folks I get to work with every day. Piping diagrams. Here's the exciting stuff. Everybody likes color pictures and no words. This is as basic as it gets, right? We've got a heat pump outside. We have a buffer tank on the inside. We have the glycol mixture that we're pulling out of the buffer tank, pumping through the heat pump, and in this case, heating it up. From there, your secondary circulator is drawing out of that heat pump, or I'm sorry, out of that buffer tank and pumping around to the rest of the system, okay? Pressure reducing valve, black flow preventer, air vent, relief valve, that's all tied into the largest volume of the system, right? The longest single volume of the system, which is very likely the buffer tank. Keeping it simple works, guys. Keeping it simple works. Same system, but let's tie in some backup heat, right? Maybe we're in a situation where, oh shit, contractor just put in a brand new boiler for a customer, but because there's rebates, they want to do some electrification, so they add a heat pump. Maybe the heat pump does some of the lifting until it gets super duper cold outside, and then it doesn't quite handle the load of the house, so we call on the backup heat, right? That could be an electric boiler, propane boiler, gas boiler, oil boiler, any combination thereof, right? Once you return the medium to the same type, hydronics, water glycol, we can use any source to make that energy, and then we just mix it together. Multiple heat pumps, okay, again, super simple. We have one primary circulator in this application with zone valves, okay. This would be my preferred method, okay, 3 heat pumps, 3 circulators. That way, it affords a little bit of redundancy if something were to happen to one of those systems or one of those circulators, right? Because so things just happen to circulators, right? Any reputable contracting firm is likely to have a circulator on their truck. Why? Because they just things just happen from time to time. Notice also in this drawing that the systems are piped reverse return. All right, that's something else that's super duper important, right? And certainly required to really make sure that we have similar flows across all units. Here's another application where we may be employing our new buffer tank / indirect tank, right? Different ways of doing things here, okay? I'm gonna talk a little bit about each slide, but likely not dissect each one unless there's a question or something on them that pops up. Understand again that you have access to this and you'll get this presentation. We're not calling out, as you can see, on any of these drawings, we're not calling out pipe size, right? Because we don't know how far away the tank is from the outside unit or the circulator is from here, or how many elbows and so on, right? These are the concepts, these are the designs, these are the basics, okay? You could do this with potentially no elbows or 72 elbows, right? We can't predict that, but what we can do is show you the right way to lay things out. A lot of times we get questions, hey, can we do heating and cooling simultaneously? Although the heat pump cannot heat and cool at the same time, heat pumps or a heat pump singular can do a very good job at maintaining 2 separate buffer tanks, one for heating and one for cooling, okay? Something super simple, we do it really quite often. And a lot of times this is needed on some newer homes that have, although very efficient energy-wise, could have very dissimilar loads, right? I might have a very high cooling load in the middle of winter in a house in Vermont because I have a lot of solar gain, right? I might need cooling in my living room in December and heating in my basement in December, right? So how would we do that, but offer up a system where we can have 2 basically batteries ready to go, two tanks stored with energy, one heating and one cooling to go to their respective emitter locations to condition those spaces. And then we've got the basic, right? Here's the basic split system diagram. Again, nothing super fancy because it doesn't have to be super fancy. You can absolutely put more than one split system together and they'll pipe just as you would with boilers, right? Very similar, be aware of piping, hydraulic separation, and all of that. Indoor unit SIS, split air to water heat pump with a boiler. Basic plumbing options for the buffer tank. okay? Sometimes you see 4 pipe, sometimes you see 3 pipe. I will always and forever suggest, recommend, and just shy of demand that you use a 4 pipe buffer tank. That is really, truly the easiest way and simplest way for you to assure that you can truly separate the flows and get the amount of flow required to the heat pump and the amount of flow required to the rest of your load, right? Without them impinging on each other, okay? You wanna get a few heat pump installs under your belt that work well, and then you wanna start looking into a 3 pipe buffer tank method, that's okay, go ahead. Some of your very first installs, or if you just wanna keep things super basic and functional, and the least amount of opportunity for anything to not go smoothly, go with the 4 pipe tank. Here's, we talked about how we're getting the energy from the heat pump to the buffer tank. Now let's talk about how we get that energy out, okay? Now generally we don't involve too much with this because a lot of times the emitters have nothing to do with anything that we offer, right? We create that buffer tank of stored energy. From what happens after that, it's you know, something that we're not necessarily aware of, right? However, as I mentioned, we cater these trainings and seminars around things that we've heard or we see on a regular basis. And one of the things that we see or hear on a regular basis, right, is what can we use on the heating side, right, or on the cooling side? What kind of emitters, right? So here's a couple options for that. But I also want to bring attention to flow on the supply side as well. One of the calls that we get regularly enough to mention it to you is that, hey, my system's not keeping up. It's not getting hot enough in here. It's not getting cold enough in here, okay? There's something wrong with your system, meaning the SpacePak system, right? It's very, very common, right? Probably the easiest thing for us to diagnose is if something's going wrong with our piece of equipment, okay? Because that's an easy fix. What's not as easy fix is trying to diagnose a potential situation where the reason for the system not operating properly is self-inflicted by the installing contractor. Sorry, guys, we've all made mistakes, right? Guys and gals, I should say. Here's the idea. We've had the calls that say, hey, my house is not heating up. Okay, well, what's the buffer tank doing? What's the heat pump doing? Oh, well, the buffer tank's at 120 degrees or the buffer tank's at 125 degrees. The buffer tank's plenty hot, it's satisfied, okay? But the system's not satisfying. So similar to if we're not running enough BT or enough flow on the heat pump side, we're not gonna get enough buffer temperature or BTUs in the buffer tank. It's exactly the same parallel to the other side of the tank. If we're not flowing enough water or water glycol, we're not flowing enough, we're not going to have enough BTUs traveling, okay? I urge you all the time, right? If you're putting in emitters, right, look at it. They will absolutely have a chart, if not they should, or something similar that says, hey, at 120 degree water in 2 gallons a minute of flow, I'm going to get X amount of BTUs. If I take 120 degree water and I pump it at 4 or 5 gallons a minute, I'm going to get far more BTUs out of that same temperature water just because I'm flowing more of it, right? That's how we get our BTUs. More flow equals more BTUs, period. So here's some options. Thermostatic radiator valves, 1 single pressure regulator circulator. Here's some panel rads, same kind of setup. Thermostatic radiator valves, this allows you, this is the heating only application, allows you some flexibility to have comfort in each room. Here's just a radiant application, right? Obviously they're small radiant loops, but for picture only in concept, this works just fine, right? Manifold, 1 circulator, thermostatic radiator valves, and zones. A couple other applications where we're actually using a zone off the buffer tank to preheat some domestic hot water through a plate exchanger. Another application where we kind of showed previously, we have a heating tank and a cooling tank, 3-way valve. We have a control that will help choreograph all of this that we're going to touch on later. slide's a bit wordy, so you'll have to bear with me when the time comes. But you can see right here, we've got heating and cooling happening in the home simultaneously. Fan coils for cooling, radiant slab, or radiant floor, radiant panels for heating. And then look, further up right-hand corner, we can tie in a boiler to this type of system as well. If I had $1 for every terrible picture I could take and show you, I'd have a lot of dollars. But I went on this project. This is a picture I took before, long before I actually worked for SpacePak in a hometown near me. I just want you to know that you could imagine walking past, this is actually the hallway of a hotel. This is in the physical hallway that someone renting a room for the night would walk past this tank and piece of abstract art, right, on their way to the room. Could you absolutely imagine that, right? Anyway, please don't do anything that looks like this. There was 4 million times that this contractor should have stopped and asked questions before they continued on. Please don't be this guy. All right, I'm going to pause for a second. I'm going to check for questions, and we're going to hop into the next section. Okay, have no fear. We are back. Ton of questions coming up. Everybody seems to be getting their question answered. So please keep them coming. Do not wait till the end and ask us a question that you could have asked 2 hours ago. Speaking of questions, one of the questions we get fairly often is, hey, I understand that your SpacePak system needs antifreeze in the system, but I don't want to put antifreeze in my system. Well, tough. But there are some options that we can do to minimize the amount of antifreeze in the system. We get asked about plate exchangers quite often. I will tell you, if nobody has ever seen the devil before, the plate exchanger is the proverbial devil. If it's not done exactly right, it will cause you nothing but trouble, okay? In this particular application, this is a terrible application because there's no water volume here, right? If we go back to our minimum required water capacity system volume for our heat pumps, there's no way there's 7.5 gallons in this little loop, right, for the system. The idea is if we're going to use a plate exchanger to separate antifreeze from non-antifreezed fluid, we're going to do that after the buffer tank. Okay, so this plate exchanger would go after the buffer tank. Here's a couple of pictures just showing some plate exchanger applications. It can be done when it's done correctly. It's really quite that simple. Hey, here's one we don't hear very often. Chilled water will result in condensation. So because we are doing heating and cooling with these, if we choose to do cooling and we're in a mechanical space or we're in an unconditioned space and we're running 40-degree water, 45-degree chilled water, okay, through pipes in a space where there could be higher than normal humidity levels, what's going to happen? Those pipes are going to sweat and they're going to condensate and they're going to drip on the ground. So we want to be very, very aware that this is going, not when or if it happens, but how much is it going to happen, right? Given the conditions of the install. Generally speaking, once you feel you've insulated the pipes appropriately, you should go back and probably insulate them some more, right? Or come back a week later and see where things stand. Sometimes adding ERV, HRV type air movement in the rooms help. Dehumidifiers in the rooms help, and things like that. Controls. I appreciate everybody bearing with us. I think we're actually moving quite quickly today. I hope we're covering all of your questions, comments, and concerns. We, I think, blocked out 3 hours for this training, and we're probably going to be finishing up here in the next 15 20 minutes or so. So we really, truly appreciate everybody's attentiveness. We still have a ton of attendees soaking it all in. How are we going to control these things, right? We kind of talked about it. Super easy. We have what we call our SpacePak system interface control, which is really an aquastat on steroids, right? Or let's not say maybe HTH or something more politically appropriate. The SpacePak SSIC control does a lot of different things, right? We'll break out into, I'm going to jump around on slides here a little bit because there's just so many words here. I'm going to go over this in a nutshell, and then we'll break out into some wiring. It has basic modes. It can be used like a basic on and off aquastat. It can accept calls from air handlers and decide that it's going to be heating, it's going to send a heating or cooling signal. It can read the outside ambient temperature and say, hey, listen, it's below 50 degrees. I'm going to send a heating call to my heat pump. It's above 70 degrees. I'm going to send a cooling call to my heat pump. We can tie in multiple tanks. Like this unit is now capable of simultaneously monitoring heating and cooling buffer tanks, okay? Whether that be a hot and a cold tank, a cold and a DHW tank, or a hot and a hotter tank, right? It also will do unit staging, okay? And that's up to 20 units. It's pretty considerable. So that's unit staging, unit rotation, all based on that. How does it wire? It's really relatively simple. Here it is, right? One of the things to be aware of, it is a very simple control, right? You can kind of see it's got a couple bars for connecting wires, and it literally has 4 buttons, okay? This is not your touchscreen phone, but I can tell you it's extremely user-friendly if you know how to go up, down, and accept or back, okay? This is something that just about everyone in SpacePak land can walk you through, but super, super helpful. That can do a lot very simply. Some of the terminals, I'll just walk through these. OA, outside air temperature sensor, that's going to go outside. Water, that's one of the sensors for either the heating or cooling tank. Return is left open. The other sensors for the heating or cooling tank, we produce our own 24 volts here, so if we need that for a relay, we can have outputs to the boiler, we can outputs to the chiller and the reversing valve to decide what mode we're going to be in, communication ports for that Modbus technology that we have since upgraded into these units. And we can accept our calls, right, from zone 1, zone 2, up to zone 5, right? And have that help us decide what our unit is going to do. It's a little bit cumbersome, this picture here, but it talks about a lot. If we're looking to look at the SpacePak SSIC control all the way to the right, we have an outside sensor, we have a buffer tank sensor, and then we have some wires that you can see they're on CHIL, so chiller, and RV. Those are the ones that go out to, guess what? Remote heat cool, remote on off. Okay, those are the ones that go out to those non-voltage terminals, the control terminals on all of our heat pumps, right? That's that common thread that runs through all our equipment, is it controls very, very, very similar from one unit to the next and from one iteration to the next. With that said, we also have the ability, oops, sorry, backing around there. Thought I had another slide in there. We also have the ability with the SSIC control to control both heat pumps and boiler at the same time. For example, this is called boiler help mode, okay? Say we are running our heat pump for heating, and we always want to run our heat pump for heating because we don't necessarily know if that load's always going to be a large load. We can set this control up so that it will monitor that tank temperature. And let's just say that we want to keep our tank at 120 degrees. 5-degree differential, like any normal aquastat, once it drops to 115 degrees, the SSIC will send a signal to the heat pump will turn on and start heating that tank back up to its set point of 120 degrees. If that temperature continues to drop, okay, we can put a low limit on it. Let's just say it's 110. If that drops below 110 for more than a predetermined amount of time, which is adjustable, right? Let's just say 5 minutes, drops below 110 degrees for 5 minutes, it will actually send a simultaneous signal from the boiler, from the SSIC to the boiler, and run both the boiler and the heat pump at the same time to bring that buffer tank back up to temperature quicker, okay? So we're calling on, maybe we're calling on a boiler, and a boiler's not a bad word, right? Boiler's not a bad word, it's a helpful word, right? The backup heat, it could be electric boiler, gas boiler, propane boiler, oil boiler. it's only going to come on when it's needed. And the heat pump control, the SSIC, can help do all of that choreography. Now, this comes the important part, and what people don't know that have jumped off before the end of the presentation is this is the way, this is the code that needs to be scanned so that you can enter as a contractor, the contractor can enter their company's information, which is the first step in registration for, okay, the first step in registration for getting your company listed as a certified contractor on SpacePak.com's website. Okay, one submit, only one from each company. Okay, scan it with your phone, fill out the information, send it into us. Okay, step one. Then we remember anything that we do in the future project-wise, we would then go on to register our equipment on the SpacePak.com website. Now, we covered a lot of information today, right? A ton of it in a relatively short amount of time. But I hope that you folks took away some of the basics. One, flow is your friend, okay? Make sure that your systems are wired right and make sure that they're piped right, okay? Read the instructions. I know it may sound silly and nobody wants to read the instructions, but I would have to say, if I was to take a poll and look at our technical service information and call logs, that more than half of the calls that come into technical service could be solved by simply reading the instructions, okay? That's not that we don't want to talk to you. That's because why not solve that problem without a phone call, right? Or if we're busy and don't answer the phone, then you're left hanging. So do your own diligence, but know that without question, when a legitimate concern, problem, question comes up, we are here for support through our pre-sale support department, for our local representatives, manufacturers representatives, who can be again located on the SpacePak.com website. Do not hesitate to ask questions. Questions are your friends, right? Because if not, they become problems in the future, right? Quite like a, yeah, I'll leave that joke alone. With that said, I'm going to pause just for a moment and see if there are any other questions, and then we have just about another slide.
When they sign off, they get a survey.
All right, remember, if we have any more questions, we have our list of reps for your territory and area that you're in. SpacePak.com/rep-locator. And then we are looking to put out another small duct velocity webinar. That date is to be determined. A lot of travel coming up in August. So sit tight and check back often for that. A little wrap up, 24 hours from now, you will receive an email that contains the links and downloads for a recording of today's webinar, a PDF copy of today's presentation, project design forms, SpacePak high resolution logos, contact information, and links to product documentation resources. Okay, so in case you forgot what Megan told you early on, here's a little reminder of what is to come. And also, please take our post-webinar survey when you sign off. I know people don't normally do this stuff. It does help us, and we really appreciate it. If you like something, tell us. If you don't like something, also tell us. It's just going to help us make things better. And again, one of the things I love about this company being relatively small is very directly your input from the field contractor, as I used to be my whole life, right? Still am at heart. It makes a difference on how we do what we do here at SpacePak. So we really, truly do appreciate and value your input. With that said, let's connect, right? We want to see your pictures, your good ones. Don't send us any bad ones, please, unless it'll end up like an episode of ridiculousness. LinkedIn, Facebook, YouTube, Instagram, all of the above. Check us out, both myself and SpacePak, all in one. So look forward to seeing you out and about, and welcoming all the questions that you may have. That's it. I'm going to pause for about 1 second and make sure there's no wrap-up questions for the folks still hanging on. Well, surprisingly, I want to thank the couple of people that appreciated today's presentation. I hope we all did at some level, some way, shape, or form. It takes a little bit for us to put these things together. It takes a little bit to talk to a computer for 2.5 hours, but we really, truly, just honestly want to get the information out there because the more educated the customer base is, the contractor base is, the more welcome new technology becomes, right? Regardless of the company that you're buying it from, even though I know you'll buy it through SpacePak because we are the best. So thanks again for hanging out with us today and look forward to connections with you all in the future. Have a great day. Thank you.